between microcontroller and microprocessors. So microcontrollers, you can say, is a single chip computer. And microprocessor, CPU which needs supporting chips. So if you see the world of microprocessor first, we have a CPU here. That CPU is connected with RAM, ROM, the output device and the input device. So this CPU can perform arithmetic and logical operation. It is a brain of, you can say it is a brain, and we need input output devices, memory. These are all supporting chips, you can say. So for example, if you go in very old microprocessors, very basic microprocessors, we will see 8085, Intel's 8086, then 286, 386, 486, T1, T2, T3, T4. Then nowadays we use I-core. Okay, so I1, I2, I3, I4, I5, and so on. So here we need help of supporting chips. We need an external RAM chip, ROM chip. For I/O, in case of old motherboards, you will see chips like 8255U. Then for timer, we can have a timer chips also. So timer chips may be 8355. Then RAM chip, ROM chips. So it becomes a very big motherboard, and everybody is a specialized one. So I/O chips are specialized chip, timer chip is specialized chip, memory chip specialized. What is the role of CPU? It can perform arithmetic and logical operations. It can understand the instructions. Where the instructions will be stored? RAM or ROM. Okay. So this was the world of microprocessor. So it's a specialized world, and you can say it's a versatile. This becomes a big motherboard. Now let us talk of the microcontrollers. In case of microcontroller, as we discussed, next we start microcontroller. Microcontrollers is a single chip solution. We have a single IC. In that IC, we have a CPU, very similar to the microprocessor. Then we have I/O ports, timer, RAM, ROM, EEPROM, EEPROM, everything in a single chip. So it's a single chip solution. So what is difference? See, in case of microprocessor world, we have a separate CPU, and that separate CPU is attached to the different sections, different other chips. In previous, like for example, timer chip, ports, I/O chips, RAM chip, ROM chip. So here it is everything in a single chip. So this reduces the size, this reduces the complexity, but at the same time, this can have, you can say, very small applications where we don't need a huge RAM, huge ROM, or we don't need a specialized timer. Even a simple timer can solve our problem. We don't need a specialized port having different modes. These ports are capable of simple input-output operations. So for such applications, we go for microcontrollers. So it saves the space, it saves the cost, it shows the block diagrams of microprocessor world and microcontroller world. Here we can see the CPU is connected with different other chips, RAM, ROM, I/O port. You can see IO port, serial port, timer. This may be parallel port, this may be serial port, timer, and all that. So we need to have address and data buses. Means, you see, in microprocessor world, the CPU is connected with the help of buses. See, this is a memory and IO devices. You can say we need address bus, data bus, and control bus. So this buses, like a buses means a pins or a path, conductive path where digital signals can flow. So we need an address bus, data bus, and control bus. Address bus is used to identify different memory and IO locations. Data bus is used to transfer either read or write the data through it. And control means control signals like read, write, or selection of IO and memory on all that. So in microprocessor world, the CPU is connected with different chips with the help of buses. CPU itself is a chip, RAM is another chip, ROM chip, and so many chips. So it becomes a big world, a big motherboard, versatile motherboard, capable of doing different mini applications. But let us come to the microcontroller world. Here we have a single chip. In the single chip, all these things are included in a single chip. Okay, so if it is a single chip solution, it may be possible that we have a very limited RAM, very limited ROM. RAM may be something in bytes. This may be in bytes or kilobytes. Okay, we have a serial port, we have a IO ports, timer, and all that. But these IO ports are not as much capable as specialized IO ports. So here we have a specialized IO port chip. For example, chips like 825 failure, chip like 8253, okay, 8251. So these are all specialized chips. So these are a specialized chips. So they are capable of doing many applications or have many facilities. But these ports are having a limited facilities, we can say. They can capable of take or send or read the data from outside world. So this may be limited RAM, limited ROM. Okay, we have a serial port which can transmit data serially to the outside world or take the data serially from outside world. So we may have a limited timers. But nowadays microcontroller world is also, you can say, day by day new microcontrollers are coming and they are having large amount of RAM, ROM, and specialized timers as well. Now question arises, which one to use for our application? When we are talking of embedded applications, we can use microprocessors as well as microcontrollers. That is not a rule that for embedded application one should use microcontroller only. But for most of the embedded applications, we can say the microcontrollers are more suitable as compared to what? Microprocessors. Because the reason is, it's a single chip, less power consumption, you can say, it reduces the size and complexity. So it is our decision whether to go for microprocessor or whether to go for microcontroller. But we can say, here since RAM, ROM are external, we can easily change the chips. Here RAM, ROM are internal, so it is not possible to open the chip and change the memory size. Okay, so once it is fixed, it is fixed. But again, you can connect external memories, external RAM, external ROM, even external ports, external IO chips to microcontrollers also. So in that case, the system will very much similar to the microprocessor world. So it is our decision whether to go for microcontroller or go for microprocessor for our embedded application. Now, what is the embedded system? Embedded system is a system which can perform a single application or a dedicated application. When you compare with a PC world, you can use your personal computer for many different purposes. Personal computer is useful for games, for seeing movies, then for word editing, then Excel, and so many applications. Or even you can run your application program, C programming, and so many things. But when you are talking of embedded application, you can say it's a single purpose or a dedicated application. For example, printer itself is an embedded system. What printer do? It just gives us a printout. You can say washing machine is an embedded system. So Embedded system means a system which is designed for a dedicated purpose, and for that system we have to give us some program. That program will be fixed program or a repeated, you can say a program which will repeat. We don't need to change the program. So that program may be stored in a permanent area, that is ROM. Okay, and in between the execution of program we may need a temporary space that is provided by RAM. For such applications we can say microcontrollers are more suitable as compared to what? Microprocessors.